given a binary search tree, find the lowest common ancestor node of given nodes in the binary search tree. According to the definition of the lowest common ancestor in the Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest nodes in T that has both P and Q as descendants, where we allow node to be a descendant of itself. Right. I think based on this definition, more confusing. I'll probably just show you what it means. Right. So for example, you're given a tree here, so you're trying to find a common ancestor between node 2 and node P and node Q. Node P is 2, node Q is 8, the lowest common is 6 because they share the same ancestor. You give another example here, P2 and Q4, lowest common ancestor is 2 because they share the same node. Do note that if they're on the same parent, if they know this is the parent of this child of this, then you return the parent, the lowest parent. Basically, it's the parent. Yeah. For example, 2 and 1. Basically, the root is 2. So it's just one node tree. Okay. So here you see here that the lowest parent between these two is 6. If it's 4, the lowest between 2 and 4 now is 2. So basically, this becomes your lowest shared node between the two nodes. Basically, the lowest shared node between the two nodes when you're going down the tree. Okay, so how do you solve this? There's a number of ways to solve this. One is what you can do is just basically traverse search the tree. Let's say you search for 2 here, and then put the result in some sort of a list, or it's 6, then 2, then search for 4. You have 6, 2, and 4, and then you do an intersection. So the going backwards. So going backwards, the lowest node that are the same, which is 2, then you get the 2. This is but the problem with this, you have to have an additional storage. So, but technically what you can do here is, instead of trying to find the intersection, what you can do is basically just search, just basically keep on searching as long as the nodes are like less than or greater, because it's a binary search tree. Take note, it's the clue here is it's a binary search tree, right? So when you're searching for a particular node, you do know that whether it's left or right. So which means you don't really have to do basically you can just make a single loop and then find 2 and 4 in the single loop. For example, like 2, right? You're trying to search for 2, so you know that 2 is less than 6 and 4 is also less than 6, so you go on the left. Now you got 2 here, so yeah, right? And then now you're trying to search for 4, right? And then you go to the right. So similar example, like say you were trying to search for, the nodes would be 8 and 2. It's the same thing. If the nodes is 2 and 8, you know that this is the shared one, right? So you can mark this as yellow. So 2 is less than 6. You go here, and but now if you start with 6, both of them are gonna start with the root node. So but you're not traversing it on the same path, like, because if you look at here, this one goes to the left, the other one goes to the right. So if they are not equal, all you need to do is break out of the loop, right, and just return this. If they are not on the same position that you're traversing, then you just break out of it. Yeah. So imagine, as long as you're on the same path, you just traverse that on the position of binary search tree, and then as long as they're not on going to traverse on the same left or right, you immediately break out of that loop. So how do you solve this? So you can create a start with a loop here for while root, basically you basically for root is not equal to you're trying to loop through the needle, right? And then if root that left, so P, you're trying to search for P, right? If root that val is less less than P, that val. So that, for example, we're searching for 2 and 4. So this should be greater than this. Typically, and root that val should be less than Q that val. This is the right, but you want to make sure that you're going to the left side of things, right? So in here, you need to make sure that root that val is also greater than Q that val. Both of them. And then you can just simply root equals root that left. You're basically just going to the left. Else if, just do the same, if root that val in the Q that val, then you switch your root now to right. Else you break out of the loop. And because basically your root is the same shared node, you means once you break out, you can just return the root. Just try it out, it's gonna work. Okay, here you go. Submit it. There you go. So can we make it faster? Not sure if there's gonna make it faster. So it varies actually. Sometimes it's less, sometimes less. But yeah, this is how you solve this using the address. So what's the time complexity? The time complexity is you're basically going through all of the node. That's a worst case solution where it's the worst case solution is everything is on the left side and just keep on going to the left. So it's the number of nodes, which is O of n. It's number of nodes. And the space complexity, we don't use any space, so it's linear. Yeah. So that's it. If you like this video, please hit like and subscribe. And we'll see you again in the next episode of Lead Coding. Thank you for watching.